Once again, this is a group number 3. Now presenting on AAE Studio. How to work with AAE Studio using Google Colab. So these two done successfully, you need to connect Google Drive with Google Colab. So first, you need to upload the data into Google Drive as we have been instructed. So we search Google Drive, then then upload your files. So here my files I'll be working with student data and wage 1 dataset. So here I move to go to Google Colab. Now search Google Colab. Here is my Google Colab site. So first of all, I will link my Google Colab with Google Drive using this command: install packages Google Drive, library Google Drive, and drive auth. This one will give me a code as an authorized code to go to step number 2. Then I'll pull my data files from Google Drive into this site using this command: drive download student data that we are going to work with and wage data set. Then step number 3, I'm going to install all the necessary tools to analyze this data. The first one is read Excel for reading Excel files. Second one, Heaven for data analysis. Then MFX for marginal effects, and LM for diagnostic tests. Here I've installed them successfully stored. Now I will start with first task from our assignment, which says produce summary statistics. So the command I will use is this one: student read Excel student dataset. I will use this student dataset to produce summary statistics. Then print out. Here there are results of summary statistics. If you can see, this tells us average and the totals of our students. There is mean, rank, and all of them. Here are summary statistics for student data. Thank you.
Hello everyone, my name is Deborah Magalera. So I'm here to do task number 2, which is OLS regression. So first of all, we wrote the data into R's brain, and then we changed the name of wage 1 to DTA, and from now on it will be called wage data. So here's the command for changing it, which is wage data less than minus read DTA bracket wage 1 to data 1. So after changing the name, this will tell R to show names of variables, exact names of the variables on the wage 1 to DTA. So after naming, after changing the name, we then do OLS regression using wage data. So wage data here. So this is the command which we use, which is model OLS less than minus IM bracket wage education plus experience data is equal to wage data. So after writing the command, you command the R to print the results on the task 2, which is OLS regression results. So here is our results for OLS regression. Thank you.
Thank you.
My name is Christian Buzo, and I will take you through diagnostic tests and explaining the results. So we did 3 diagnostic tests, which were heteroscedasticity, which checks if our wage dataset has errors, and the normality test, and also the multicollinearity test. So to do the heteroscedasticity test, we used the command library linear model test, which is a Bluch-Bagan test. So after running the heteroscedasticity, here are the results that we got. And to run the normality test, we use the command Shapiro test residuals model OLS, which gave us those results. And for us to do multicollinearity test, we had to install a package CAR, which enables the VIF test to work. So after installing the package, we used that command, library CAR and VIF model OLS, and those are the results. So the interpretation of this diagnostic test in heteroscedasticity, the p-value was less than 0.05, which is the alpha value. So this shows that there is a presence of heteroscedasticity. And in normality test, the p-value was less than 0.05 as well. So it shows that errors are not normally distributed. And in multicollinearity test, here we installed the package CAR, then VIF of the VIF of both education and experience was approximately 1.09. So this shows there is no significant multicollinearity issues. Thank you.
Thank you. Loud and clear.
Hello guys, we are on test 4, which we are required to run a logistic regression model using the LW dataset. So we access the LW dataset using the codes below. That's from the if up to the data. After that, we are going to, we did a logistic model using the command logit model, which is low approximately equal to age plus range plus race plus smoke, which is in the data set. To access the results, we will do summarize the logit model, which we are getting the results below. Thank you.
Thank you.
Hello, my name is Kovahi Walindil, and I'm going to show us how we run the probit model. So first of all, we are going to enter a command that is going, the one that I'm showing here, that is going to show how age, race, and smoke affect dependent variable low birth rate. So after that, we're going to insert a command summary probit model that is going to display the results. Thank you.
Thank you.
My name is Chisomo Mendi. So the last task we are asked you to do is to get marginal infection. So since we are having 2 models, which is logit and probity, we are going to first calculate the marginal effect for logit model. So as illustrated in the code below, the command to calculate the marginal effect is margins probit model. So as you can see, this is our results, the marginal effects for probit model. Another thing, the last thing also is to get the marginal effect for probit model, and the command is margin for probit model as illustrated And after running the command, this is our results. Yeah, that marks the end of our video. Thank you.
Thank you.
Thank you. I don't go thank you.